Okay, we were discussing about the we were discussing about the comparator, and we have seen how we can use the Zener diode for limiting the voltage, the output voltage. So we will see one more type, which is known as the double bound comparator. Double bound comparator. Okay, so here actually we can limit the output voltages for the negative and the positive part. Okay, so we will see this circuit first. You see, this is minus, and this is a zero reference. Actually we have given the reference voltage as 0 volt. Now we will see here, we have Ri, and this is your V in, maybe something like a sinusoidal wave, or maybe sometimes the triangular wave, and this is V out. Okay, and you have a feedback path, but here is the difference. You can see here there are two Zener diodes which are connected in opposite directions. Okay, like this. Okay, now we will see what will happen when the output become negative and positive. For example, you know that this is the difference voltage Vd. If Vd is greater than 0, actually due to the high gain of the op amp, if Vd is greater than 0, the output will go to positive, and if Vd is less than 0, the output will go to negative. Suppose you have VCC plus VCC and minus VCC, but so you will be getting the output like, whenever the input is positive, since the input is connected to the inverting terminal, when the input is positive, your Vd become actually negative. That means the output will be going down, similarly going up like this. Okay, so this is the expected output. But what is this voltage range? What is the output voltage here? If there is no feedback path or Zener diode, you may get the output voltage as plus VCC, minus VCC, or plus VCC. But here there is a feedback. You can see there is a feedback here. There is a feedback. So you will not get a VCC or minus VCC. So what will happen if the output is maximum? Let us assume that the input is positive. That means this particular half cycle. Then if input is positive, then what will happen? That means that your Vd is nothing but V reference minus V in. Since V in is positive, your Vd will be less than 0. That's why, because V reference is 0, so 0 minus V in become it's become less than 0. Now what will happen? The output may move to a negative voltage. Since the output is a negative voltage, you know that this is p-type semiconductor and this is n-type, and for the diode this is the anode and this is the cathode. So what will happen to, let's say this is diode 1 and this is diode 2. What will happen to diode? Now V out, you will say V out moves to a high negative voltage. So what will happen? So if it is negative voltage, you know that this negative is connected here. This is negative, output is negative, so this is negative. Now this may be positive, right? And the input is positive, so this end you are giving a positive, and this is you are giving a negative voltage. Now what is happening? Now you see here that you are getting the diode D1. The diode D1 is in which bias? Diode D1 is in, you are applying the P part, actually you are applying to the anode with a negative voltage. So diode D1 is reverse bias, and diode D2, you know that this is negative and this is for positive, right? So diode D2 is forward bias. But when it is reverse bias, you know that the voltage will be Vz, and When it is forward bias, the voltage will be 0.7. So the polarity will be like exactly same like this. So minus plus, right? So this will become actually the diode D2 as 0.7 like this here, and this voltage is Vz. So these two are in series. They are in series basically. So what is the total voltage? So the total voltage, so the total voltage will be how much? So the total voltage, I will write it here itself. The total voltage at output, at V out, is equal to minus of 0.7 plus, I will write it in the next voltage, next line. So V out is equal to, you know that this voltage is minus 0.7 because we are talking about V out. So at V out, the voltage polarity, it is minus, and again you have a minus. Okay, so plus, you have a minus, so minus Vz. So this become minus of Vz plus 0.7. So that will be the output. So this output will be minus of Vz plus 0.7. Now this Vz, I can say this is the diode 1, so I will call it as Vz1. So Vz1. Okay, so that is Vz1. Now we will see the next case, that is, we will see when the, notice the color I have used here, okay, green, I will use another color. When V in is negative, so what will happen to Vd? Vd is equal to V reference minus V in. That means the overall voltage become actually positive. So Vd is positive now. So what will happen? V out also will be positive. So we will see what will happen when V out is positive. So when V out is positive, you know that this diode, across this diode, this positive and negative, again you will get positive and negative because this is positive and this is also positive. So what is happening to diode D2 and D1? So diode D1 now in which bias? Diode D1 is positive and negative, it is in forward bias. Okay, and diode D2 is in reverse bias. So what is V out? It is nothing but the voltage across these two diodes, because you know that it is nothing but because this is also ground. That's why we are measuring like that. Okay, this is like a ground, actually it is like a ground because of the virtual short due to feedback. Now you know that the voltage across D1 is, okay, fine. Now the voltage is nothing but the voltage across D1 plus the voltage across D2. How much? Voltage across D1 is minus, am I correct? Yes, not minus, it is plus, sorry. D1 is plus 0.7 because this is forward bias, 0.7, and this is Vz2. So 0.7 then plus Vz2. So what is V out? V out is equal to Vz2 plus 0.7. So that is the output. So this voltage become Vz2 plus 0.7. So that's it. So this is the idea. Okay. So I believe that it is clear to you. This problem is clear to you. Okay. Next, we will see another important type of circuit, which is known as a Schmitt trigger. Okay, this is one of the important circuit. Okay, it is a comparator with a positive feedback. We will see how we can use of positive feedback, make use of positive feedback. Okay, Schmitt trigger, Schmitt trigger circuit. Okay, it is a comparator. Basically this is another kind of circuit which is a comparator, but it has a feedback circuit with it's a comparator circuit with a positive feedback. Okay, so it can be actually it is having a particular phenomenon which is known as the hysteresis that we will discuss. So first of all we will see what is the circuit diagram. This is plus minus, and you can give the input here V in. Okay, and this is R1 and this is R2. That's it. Okay, now this is a positive feedback. Okay, so the basic operation can be when the basic operation can be explained as follows. Okay, so you can see here this is V out. Now you see here what is the difference voltage between these two. It is nothing but Vd, and the open loop gain is AOL. So what is Vd and AOL? Okay, now we will see what will happen if we give an input to this circuit. So I will draw the circuit diagram again. And this is R1 and this is R2. Okay, and V out and this is V in. You can see that this is a positive feedback because the feedback is connected to the non-inverting terminal, that is this terminal of the amplifier. Okay, now you can mark the Vd here, and this is AOL. I can give some input like a sinusoidal wave, so I will show with this. So this comparator, the reference voltage you can mark like this. This is your reference voltage, but reference voltage, you see, it is directly related to the output. Okay, so this reference voltage is directly related to the output. So the reference voltage can be, if the output is positive, the reference voltage also will be positive. If the output is negative, okay, if the output is negative, the reference voltage also will be negative. That is the thing. That is, the reference voltage is not fixed here like in the previous circuit. In the previous circuits you are fixing the reference voltage, but here the reference voltage is not fixed. Now this is your V in, this is your V in, and it is having some positive part and negative part. So if we can consider your output can be either positive, or V out can be negative, right, according to the Vd. Okay, if Vd is positive, this will happen if Vd is greater than 0, and this will happen if Vd is less than 0, right? Because, and what is Vd? Vd is nothing but V reference minus V in, right? Because that is Vd that we have seen already in the previous circuits. Now what will happen? Okay, we have only two conditions, so I will take any one of the condition and I will proceed. Assume that your V out was positive. That means it was greater than 0, or you can say it is positive. It is positive. So if V out is positive, what will be V reference? We can find V reference as V out divided by and V out will be maximum, like plus VCC or minus VCC, like VCC and minus VCC. So V out can be maximum. Okay, so V out I can write like this maximum also, because output will move only to the maximum. So V out max divided by R1 plus R2 multiplied with R2, and we will call this as upper trigger point. This V reference we will call as upper trigger point. Why it is upper? Because it is high, maximum, and it is positive. Okay, so this V reference is positive. So this V reference, this positive V reference, we will call VUTP, upper trigger point. This is U, upper trigger point. I am going to mark it. Since it is positive, it will be upper, that's why. Okay, upper trigger point. Now what will happen, and we have one more thing. So this is upper trigger point. Now VLTP, we do have one more thing, VLTP, which is known as the lower trigger point. Same, this will happen when V out is negative, V out is less than 0, or you can say negative. So what is this? It is nothing but minus of V out max. It's negative voltage, so minus of V out max divided by R1 plus R2 multiplied with R2. So this is up lower, so we will call this as lower. So this will happen only if you have a lower trigger point. So this is the lower trigger point, so your V reference is having now two values basically, that's why. Now this is upper trigger point, so your output can be positive or negative. According to that, it will be showing this kind of behavior. So this is the definition regarding the upper trigger point, and I have another thing. This is the lower trigger point. Okay, lower trigger point. So this is the lower trigger point, and this one is the upper trigger point. We will see all this equation in detail. Now let us assume that the output was positive. If the output was positive, okay, I will use a different color. Assume that the output was positive. If the output was positive, what will happen to this voltage V reference? Now V reference will be V upper trigger point if output is positive. Now what is happening here? Output was positive and this is your reference voltage. Now you see here your input voltage at t equal to 0. This is the time t equal to 0. Your input voltage was something, as less than your input voltage was less than VUTP. So if you take these points, your V in is less than VUTP. So if V in is less than VUTP, then VD is nothing but VUTP minus V in, and this number will be greater than 0. So what will happen if VD is greater than 0? Your output will be also greater than 0, right? That's what happening. So I have no space here. So this is what happening here in this zone actually. So I can mark like this here. Okay. Now what will happen if the input become greater than VUTP? We will see these are all the points where the input is greater than VUTP. Then what will happen? Your VD will become greater than 0 or less than 0. It will be, what is VD? VD is equal to VUTP minus V in. So what will happen? What will happen to this point? Actually, at this point, VD minus V in. So VD become less than 0. That means that V out become less than 0. So output will change the direction. You see, The output is changing the direction throughout this point. So when our output changes the direction, now the comparison point is nowhere. Now the comparison point V reference also will change. Since the output is less than 0, whenever the output is less than 0, you know that the comparison point, that means it become now VLTP. Now the comparison point is not VUTP. The reference has changed to VLTP. Now we will see. Now the comparison point is here now on this. Okay. Previously the comparison point was this one. Now the comparison point changes. So up to this point the comparison point is same. Now the comparison point has been changed. That means the reference voltage has been changed. Now it is here. Okay. So what is happening now? Now you see, I will use a different color. Okay, fine. Now the output has changed to minus. Now the comparison point is VLTP. So you see here, now the comparison point is VLTP. This is now the comparison point. So what is happening? The comparison point has changed. Now we will see some point here. At this region, your Vin, you see this is your comparison point. So at this region, your Vin, you can see this region, your Vin is greater than VLTP. If Vin is greater than VLTP, what is happening to VD? VD is equal to VLTP minus Vin, right? But Vin is greater than VLTP. So VD is less than 0. So output also will be less than 0. That means output will be remaining in the same position. Now we will see another points. Let's say this area. At this area it is different. V in is less than VLTP. So what is happening? If Vin is less than VLTP, then output will change, right? Is it? Yes. At this area, will it change? Vin is less than VLTP. Let us assume that, okay, I will give an example in the next page anyway. So at this point you know that your Vin is less than VLTP, and what is our VD? VD is equal to VLTP minus Vin. If Vin is less than VLTP, what will happen? Will it change? Because whenever this point started, what will happen? Will it change or not? So suppose VLTP is 10 volt and Vin is less than VLTP. It is VLTP is minus 10 and Vin is minus 12. So this become positive number. So this VLTP minus Vin become greater than 0. So Vout will again change to Vout will again change to greater than 0. That means it will change to positive. So there is a trigger here. Okay, there is a trigger here. And similarly, previously, here also actually the output is changing. So here also there is a trigger. You see this one, there is a trigger. So that's what we are going to see now. So I hope this is understood. Now we will see an example, then it will be clear to you. So let us assume that you have a Schmitt trigger, minus, plus, and this is 10 kilo, and again this is also 10 kilo ohm. Okay, and this is plus 10 and minus 10. Okay, I am giving some voltage here. This is changing like 5 volt to minus 5 volt. Okay, this is Vin. So this is a Schmitt trigger circuit. So you can have two things in your V out. So your V out can be, so I am going to write the answer. So draw the output of this circuit. Draw the output. Now you see your V out can be greater than 0 or your V out can be less than 0. So what are the outputs now? So you can have two outputs. If V out is greater than 0 means V out, whenever V out is positive, it becomes positive 10, right? Because maximum is positive 10. Okay. Now V out is negative means that it can be minus 10. So you have only two possibilities. V out can be either plus 10 or minus 10. Okay. Now I will first draw the input. Okay, draw the input. Now I will just draw VLTP and VUTP. I will just show what is VLTP is equal to 10 minus 10 divided by, because VLTP means lower trigger point, so we will take the minimum voltage. Okay, minimum means maximum negative, that's it. Okay, so it's minus 10 divided by 10 kilo plus 10 kilo into 10 kilo, which is equal to minus 5 volt. So here I will draw my V. Okay, this voltage is not enough. I will change this to 8 volt and minus 8. So this become 8 volt and minus 8. Okay, 8 volt and minus 8 volt. So this become now minus 5 volt. Okay, similarly you can find VUTP, which is equal to plus 10 divided by 10k plus 10k into 10k. Okay, so that's it. Now how much it will come? It will come around, yeah, it is 5 volt. So you got it, 5 volt. Okay, so this is the VUTP and this is the VLTP. Okay, now we see I am going to draw the output. So before drawing the output, I will just draw a line to make it correct. So you see here I have a lot of points, transition points. I will draw all these transition points for drawing it correctly. We will see at which transition point the changes will occur. Okay. Now I told you I will start with the assumption now. Its output was positive. If output was positive, then what will be the, if the output was positive, what will be the output at this point? Let's say yeah, it is comparing. If output was positive, this will be 5 volt. So, and you see here at this portion we have Vin less than 5 volt. If Vin is less than 5 volt, that means that the output will be positive. So output will be always positive. So this positive output will be just 10 volt plus 10. So output will be positive. But whenever you reach at these points, at this point actually Vin is greater than VUTP. That means Vin is greater than UTP. Means what? Your UTP is 5 volt. So this can be plus 5. This is plus 5 volt. So Vin is greater than VUTP, means it is greater than 5 volt. That means that output Vd become negative, so the output will be switching. So the output is switching now, and output is switching to minus 10 volt. So whenever output switches to minus 10 volt, you know that whenever the output switches to minus 10 volt, so previously it was 10 volt, now the output switches to minus 10 volt. So what will happen? This will switch to minus 5 volt. Okay. So now the input is comparing with this minus 5, but input is greater than minus 5 always, and up to this point your input is greater than minus 5. So all these points, actually it is showing their input is greater than minus 5. So up to this point there won't be any change in the output, but whenever you reaches at this point, again another trigger will occur. That means that your input is going below your UTP. So what is happening, whenever input become less than the LTP, so when Vin become less than VLTP, what will become Vd? What is Vd? Vd is nothing but VLTP minus Vin, which become a positive number. That means that your output will be going again, okay, output will be going again up, right? But this will continue till this portion as shown here. So this will continue up to till this portion, and the output will remain like this. Similarly, at this portion, you see, since the output is positive, now you have 10 volt, so the output will be 10 volt, and your voltage at reference, it will switch to VUTP. That means it become again 5 volt. Now your Vin up to this point, the Vin is less than VUTP, so the output will be positive. But when you reach at this point, when you reach at these points, that means when you reach here, again what is happening, your Vin become greater than VUTP. That means Vin become greater than 5 volt. That means if Vin is 6 volt, for example, then 5 minus 6 is a negative number, then output will be switching again, right? So this will continue up to this point, then again it will be switching again at this point, okay, and this will continue, okay, then again it will switch here. So this is the Schmitt trigger. So I hope this is clear to you. Now you should understand that the voltage at you should understand that the pulse width of the pulse is actually depending upon the difference between VUTP and VLTP. So what is happening here basically, whenever your input voltage is between some range, you see here, you are getting, suppose your input voltage is, you can see here, I will mark with a different color. You can see at this portion, you can mark this portion, similarly this portion. So what is happening here, you can say that at this portion your input is between VUTP and VLTP. Your input is between VUTP and your input is actually above VLTP. Your input is above VLTP. That's what. The input is above VLTP. Your Vin is above VLTP. Okay. Input is above VLTP. Now if you take at these points, what we can say, your input is below VUTP. That's why. So you can have a two different comparison. So you are actually comparing with two voltages simultaneously. So by controlling the values of R1 and R2, you can fix VLTP and VUTP. But you may think that if you change R1 and R2, VLTP and VUTP will be changing in the same fashion. But by connecting some diode circuits, you can control this. But anyway, this is enough. So I hope the basic understanding of you have got the basic understanding of the Schmitt trigger. Okay. Next, we will see another important circuit which is known as the summing amplifier. How we can add two voltage signals. Okay. So we can add, first we will see how to add two voltage signals. Next we will see how to add many voltage signals. Okay. So this amplifier we will call it as a summing amplifier. Summing amplifier. Okay. And we will see it is having a gain of unity. Okay. What is happening here? Okay. So basically it is a inverting amplifier. Okay. So we will see the circuit diagram. Minus, plus. Okay. And this is R1 and this is R2. You see there are two inputs, V in 1 and V in 2. We want to add two voltages, V in 1 and V in 2. Next, here it will be connected to the ground. Now this is your RF and V out. Okay. We will first do the circuit analysis. If you connect like this, what will happen? You know that this voltage is 0 volt. So at this point also it's 0 volt due to the virtual short. Okay. Now I am assuming that all the currents are moving away from me. Okay. This current is I1, this current is I2, this current is I3 and this current is I4. Now I will apply the KCL. This is very easy to analyze. Apply the KCL that I1 plus I2 plus I3 plus I4 equal to 0. And what is our I1? That's what we are going to see. I1 is nothing but this voltage is 0 volt. I told you this is 0 volt. So 0 minus V in 1 divided by R1. If V in was positive, you will get the current, the magnitude of I1 as negative. That means that actual direction of the I1 is opposite to your assumption, but that doesn't matter anyway now. And what is I2? I2 is equal to 0 minus V in 2 divided by R2. And what is I3? I3 equal to, which is going into the op amp. I told you the current going into the op amp is 0 ampere. And what is I4? I4 is nothing but 0 minus V out, because it is directly connected to the output, divided by RF, right? Now I will add all these currents. So I1 plus I2 plus I3 plus I4 equal to 0. And I1 was 0 minus V in 1. 0 minus V in 1 is nothing but minus V in 1 divided by R1 plus I2 is minus V in 2 by R2 minus V in 2 by R2 plus then I3 equal to 0 plus I4 equal to 0 minus V in V out. That means minus V out divided by RF. This is equal to 0. So I can measure my output now as V out. I can take this guy to the right side. So V out by RF is equal to minus of V in 1 divided by R1 plus minus of V in 2 divided by R2, right? So what is V out? V out is equal to RF, and I can take my minus sign here, RF into V in 1 divided by R1 plus V in 2 divided by R2. Am I correct? So this is my output. Now I am talking about something having a unity gain. Okay, unity gain. Okay, I am talking about this. Now you see, if Rf equal to R1 equal to R2, I choose, if I choose Rf equal to R1 equal to R2, then what will happen? My output was like this, minus of Rf into V in 1 divided by R1 plus V in 2 divided by R2. Okay, if I choose all this as same, if Rf equal to R1, then you see here I can cancel out. If R1 equal to Rf equal to R2, then what will happen? All this will cancel out. For example, I can write like this, minus of Rf by R1 into V in 1 plus minus of Rf by R2 into V in 2. But if Rf equal to R1 equal to R2, what will happen? This will cancel and this will be 1. This will cancel and this will be 1. That is nothing but the unity gain, you can say. The gain become unity. Okay, so the gain is now depending only on Rf and R1. So what is V out now? V out is equal to minus of V in 1 plus minus of V in 2, which is nothing but minus of V in 1 plus V in 2. That means you are getting a negative sign, that doesn't matter, but you are getting the sum of voltages, okay, that's it. So that is known as, this is nothing but the summing amplifier. That's why we are calling it as a summing amplifier. If Rf is not R1 or it's not equal to R2, then it is a summing amplifier, but it is not having a unity gain. But this is having a unity gain. We will see an example now. So let us see one example. You have a circuit like this. This is 10 kilo ohm. This is also 10 kilo ohm. Okay. Now this is your V out. You have another. This is 10 kilo ohm, and you have one more. Now you see I have connected three things together. This is also 10 kilo ohm and this is ground. Now this is 1 volt, this is 2 volt and this is 3 volt. Okay, I want to add all these voltages. That's why this is a summing amplifier. Summing amplifier. Okay, summing amplifier. Now you see what I am going to do. I am going to assign this voltage here. This is 0 volt, so this is also 0 volt. Now I will assign the direction of current I1, I2, and this current as I3, and this current as I4, and this current as I5. Now I can write the KCL. I1 plus I2 plus I3 plus I4 equal to I4 plus I5 is equal to 0. Am I correct? Yes. Now what is I1? I1 is equal to 0 minus 1 divided by 10 kilo, and I2 is equal to, what is I2? 0 minus 2, this is 1 volt, this is 10 volt, sorry 2 volt divided by 10 kilo, plus I3 is equal to 0 minus 3 by, this is also 10 kilo, okay, 10 kilo, and I4 is equal to 0, then I5 equal to 0 minus V out divided by 10 kilo. So if I substitute in this equation, it become minus 1 divided by 10 kilo minus 2 volt divided by 10 kilo minus 3 volt divided by 10 kilo plus 0 minus V out divided by 10 kilo. This is equal to 0. So I can solve this equation. I can find my V out. What is my V out? V out is equal to minus 10 kilo ohm multiplied with minus 1 by 10 kilo minus 2 by 10 kilo minus 3 by 10 kilo. All these are in voltages. Then this is kilo ohms. Okay. So this will cancel. This 10, this 10, this 10, this 10 will cancel. So I will get it as, this is not minus anyway. I will get it as minus of 1 plus 2 plus 3 volt. This is my V out. So my V out is equal to minus of 6 volt. So that's how we are getting the output. So you are actually adding all this. So that's why this is a summing amplifier. Okay. Now we will see another example. I think this is clear to you. We will see another example. So let me put this one as the question 1, another one as the question 2. I have 2, this is 1 volt and this is 2 volt and this is minus, this is plus, and I'm connecting a feedback like this. Okay. Now let's say this is 10 kilo ohm and this is 5 kilo ohm and this is 5 kilo ohm. Then what will happen? We will see. If I am putting 5 and 5 and another one is 10, that means my RF equal to 10 volt and my R1 is equal to, sorry, not volt, 10 kilo ohms, and R1 is equal to 5 kilo ohms and R2 is equal to 5 kilo ohms. Okay, now we will see. So the answer, I am going to assign the voltage, this is 0 volt, so this is also 0 volt. So my current, this is I1 and this is I2, and this current, okay, I will connect it here itself, then you can avoid the confusion. Both are same anyway. And this current is I3 and this current is I4. So I1 plus I2 plus I3 plus I4 equal to 0. And what is I1? I1 is nothing but 0 minus 1 volt divided by 5 kilo ohm. And what is I2? This is 0 minus 2 volt divided by 5 kilo ohm plus what is I3? It is 0 plus what is I4? 0 minus, this is V out. So V out divided by 10 kilo ohm, this is equal to 0. Now this become minus 1 by 5 kilo ohm minus 2 volt divided by 5 kilo ohm is equal to, I will take this guy to the right side, so it become V out divided by 10 kilo ohm. Now I can rewrite the equation. I will write this part first. So V out divided by 10 kilo ohm is equal to minus of 1 volt divided by 5 kilo ohm plus 2 volt divided by 5 kilo ohm. Okay. So what is happening here? Okay. Now you see here, V out is equal to 10 kilo ohm, and this is 5, actually this is common, this 5 and this 5 I can take it outside, so this become minus into V1. That means V1 is nothing but your 1 volt plus 2 volt. So this is nothing but minus 2 into 1 volt plus 2 volt. Now you see here, this is our gain, and this gain is not unity, okay. So this is another amplifier, this is also a summing amplifier, but gain is not unity. Okay, now we will see one more circuit. Okay, so what is that? So in this example, in the previous example, I have chosen my R1 equal to R2, and which is equal to RF by 2. Okay, it is nothing but RF by 2. Or I can say that my RF equal to 2 times R1, which is equal to 2 times R2. Okay, this is what I have used the condition. But if I use an opposite condition, now we will see one example. This is another connection. We will see another example. Let's say this is R1, R2 and R3 and V1, V2 and V3, and this is my minus plus, okay, and I connect my feedback resistance RF, and this is my V out. I know that my output is V out is equal to minus of RF by R1 into V1, because from our previous problem we have seen already this. Okay, I'm not going to write it again. You see, we have already seen this. This is nothing but, you see, this is V out is equal to minus RF by R1 into V1 or V in 1 plus minus RF by R2 into V in 2. Okay, so the same thing. So minus R1, okay, this is V in 1 anyway, this is V in 2, I will use the same notation, V in 3. So V in 1 plus minus RF by R2 into V in 2 plus minus RF by R3 into V in 3. V in 3. Okay, and you know that there are three inputs. There are three inputs. So in general we have n inputs. We can say I am going to choose my Ri. Ri means I can be 1, 2 or 3. That means R1 or R2 or R3. 1, 2 and 3. I am going to choose my Ri is equal to n times Rf, or I can say my Rf is equal to Ri by n. Then what will happen? This implies that Rf by Ri is equal to 1 by n. So in this circuit our n equal to, in this circuit actually our n equal to 3. So here I am going to say that Rf by R1 is equal to Rf by R2 is equal to Rf by R3 is equal to 1 by 3. Then what will happen for the above example here? Okay, so what will happen here? Now V out is equal to minus Rf by R1 plus, into V in 1, I will rewrite it again, plus minus Rf by R2 into V in 2 plus minus Rf by R3 into V in 3. So if Rf by R1 equal to Rf by R2 is equal to Rf by R3 is equal to 1 by 3 for this example, because there are three inputs are there, that's why. Okay, then I can choose my Rf is equal to R1 by 3, which is equal to R2 by 3, which is equal to R3 by 3. Okay, this is my Rf. Okay, that means everything is equal, for example. So what will happen now? So Rf by R3, then this equation become V out is equal to minus of, this become 1 by 3, this guy become 1 by 3 here. Okay, everywhere it's become 1 by 3. So minus 1 by 3 into V in 1. Okay, I can take it common, that's why it is V in 1 plus V in 2 plus V in 3. So what it is? Actually 1 by 3 multiplied with V in 1 plus V in 2 plus V in 3. It is nothing but the average, right? Because how you will find average? You will actually add everything and divide by total number. So this is nothing but the averaging amplifier. So here this is averaging amplifier. So for averaging amplifier, what is the condition? Your Rf by Ri should be equal to 1 by n. That means this is the averaging amplifier. So this amplifier we will call it as averaging amplifier. Now you can find the sum and average amplifier. So that is the beauty of op-amp. You can make a lot of things by changing the resistance. So in averaging amplifier, your Rf by Ri is equal to 1 by N. This is the condition. Okay, so I hope this is clear to you. We will see one problem. Okay, after that I will wind up. So let us consider this is minus, this is plus. Okay, this let's Rf by R1, and this is your Rf, this is your R1. Rf by R1 is equal to 1 by N, means that for averaging amplifier, Rf by Ri is equal to 1 by N, right? So what is Rf equal to Ri by N? I am just considering two inputs here. Okay, so let's assume that Ri is equal to 10 kilo ohm. So Ri is equal to 10 kilo ohm, and this is also as 10 kilo ohm. So my Rf will be equal to, then this is the assumption, then Rf will be equal to 10 kilo ohm by, there are two inputs I am considering, so it's become 5 kilo ohm. Okay, so this I will choose as 5 kilo ohm. So this is V in 1 and this is V in 2, and this is my V out. Now you see here, you can compare with the previous problem that I have solved. This is, I am choosing here as 5 and 5, and this is 10. Now I am choosing 10, 10 and 5. So now I am choosing this is 10, this is 10, and this is 5. So that is the difference. Now I can write my V out as what? V out is equal to, let's say this is equal to 2 volt and this is equal to 3 volt. So my V out is equal to minus of Rf by R1 into V in 1 plus minus of Rf by R2 into V in 2. And what is my, so what is my output now? So V out is equal to minus of Rf is 5 kilo ohm divided by 10 kilo ohm, and V in 1 is 2 volt plus minus of 5 kilo ohm divided by 10 kilo ohm into 3 volt. So what is happening here? This is minus 1 by 2 into 2 volt plus minus 1 by 2 into 3 volt. This is nothing but minus 1 by 2 into 2 volt plus 3 volt. That's the answer. That's the average. Okay, you are getting a minus sign. You can avoid this minus sign. How you can avoid this minus sign? How to avoid or remove this negative sign? Do you have any answer? Okay, for example, you have an amplifier minus plus like this. Okay, this is your R1 and this is your R2 and this is your V in 1 and V in 2, and you can have something like Rf here. That's it. So what is your output here? V out 1, this is the first stage, I would say. It is minus Rf by R1 into V in 1 plus minus Rf by R2 into V in 2. Now I will connect another thing which is known as a voltage follower, minus plus. Okay, you see here, I will connect like this. Now what is the gain of this amplifier? The gain of this amplifier, magnitude of the gain is the magnitude of the gain. What is the gain of this amplifier anyway? Okay, I will connect not like this, sorry. If I connect like this, it is not a good circuit. Why? Why it is not a good circuit? For a voltage follower, I will connect the input like here. I will connect the input here for the voltage follower. So, but I am not connecting the input here, but I will connect like this. This is 1 kilo ohm resistance and this is 1 kilo ohm resistance. Then what is the gain of this? Gain is equal to minus of 1 kilo ohm divided by 1 kilo ohm. Okay, so this become minus 1. So this V out 2 right? So V out 2 will be equal to minus 1 multiplied with V out 1, which is equal to, you will get the answer as Rf by R1 into V in 1 plus Rf by R2 into V in 2. According to the value of R1, Rf and R1 and R2, you can configure averaging, summing, whatever you want. Okay, so that's it. So inshallah we will continue in the next lecture. Thank you.